Hi, welcome to my YouTube channel Electronics for Gate by Kota Venkanna. My mobile number 630-5826-909. Today I want to discuss the topic in transmission lines, that is input impedance of open and short circuited lossless transmission lines. So here in this, for the lossless transmission lines, the input impedance of the open circuit and short circuit can be derived from the general transmission line equations. So the general transmission line equations, V is equal to Vs cos HPX minus Is Z0 sin HPX. I is equal to Is cos HPX minus Vs by Z0 sin HPX. So these two equations are current and voltage equations are general transmission line equations. So here for the lossless transmission lines, the length of transmission line should be assumed as L, that is independent represented with L. So in the place of X we have to substitute L, and in the place of V we have to substitute V suffix R. VR is the load voltage, and in the place of I we have to substitute IR. IR is the load current. Here coming to the point, here P is there, propagation constant. P is propagation constant, that is represented with alpha plus J beta, where alpha is the attenuation constant and beta is the phase shift. So for the lossless transmission lines, the attenuation constant alpha equal to 0. So we have to substitute 0 in this equation, then propagation constant P is equal to 0 plus J beta. So in the place of P we have to substitute, that is only J beta. That is only J beta. So in the above equation, X is equal to, in this equation X is equal to L, P is equal to VR, I is equal to IR, P is equal to J beta, substitute. Then the equations becomes VR is equal to Vs cos H of J beta L. In the place of P we have to substitute J beta into L. In the place of X we have to substitute L minus Is Z0 sin H of J beta into L, and then IR is equal to Is cos H of J beta L minus Vs by Z0 sin H of J beta L. But cos H of hyperbola cos J beta L equal to cos normal cos beta L. Similarly, sin H of J beta L is equal to J of sin beta L. So that's why in the place of cos H of J beta L we have to substitute cos beta L, and in the place of sin H of J beta L we have to substitute J sin beta L. So then the equation becomes VR is equal to Vs cos beta L minus J Is Z0 sin beta L. IR is equal to Is cos beta L minus J Vs by Z0 sin beta L. Then, so here first of all we have to discuss for the open circuit. So here this is the open circuit. So this is the ZOC is the open circuit input impedance. So Z0 is the characteristic impedance and L is the length of the line. So here output is open. Then when the output is open, VR is maximum, load voltage is maximum and load current IR is equal to 0, and when the IR current is 0, impedance, output impedance is infinity. So then these values VR is equal to IR is equal to 0, substitute in the above equation. IS is equal to IR is equal to IS cos beta L minus J Vs by Z0 sin beta L. Then we have to substitute to IR is equal to 0. Then IR is equal to 0. 0 is equal to IS cos beta L minus J Vs by Z0 sin beta L. Then equating these two, IS cos beta L is equal to J Vs by Z0 sin beta L. But here input impedance of open circuit ZOC equal to Vs by Is. Input voltage by input current equal to input impedance. That is input impedance represented for the open circuit represented as ZOC, Z suffix OC, that is equal to Vs by Is. Then the above equation is written as Z0 by Z0 cos beta L by J sin beta L. But here 1 by J is equal minus J and cos by sin is equal cot. So here cos beta L by sin beta L equal to cot beta L. Then for the open circuit, the input impedance equal to minus J Z0 cot beta L. This is the input impedance for the open circuit of lossless transmission line. Then we have to find out for the short circuit. So for short circuit, the input impedance for the short circuit lossless transmission line is, so this is the short circuit. ZSE is the input impedance. Then we have to find out the ZSE input impedance. L is the length of the transmission line, and this is output is short circuited. When the output is short circuited, then output voltage VR is equal to 0, and then output current IR is maximum. Then current is maximum, impedance is equal to 0. That is load impedance ZR is equal to 0. So here the basic equation VR is equal to Vs cos beta L minus J Is Z0 sin beta L. So in this basic equation we have to substitute to VR is equal to 0. VR is equal to 0. Then 0 is equal to Vs cos beta L minus J Is Z0 sin beta L. Then equating these two, then Vs cos beta L is equal to J Is Z0 sin beta L. But input impedance of short circuit ZSE is equal to input voltage by input current, that is Vs by Is. Vs is the source voltage, Is is the source current. Then ZSE, that is the input impedance of short circuit is equal to Vs by Is is equal to Z0 sin beta L by cos beta L. But sin beta L by cos beta L is equal to tan beta L. So that's why ZSE input impedance of short circuit is equal to J Z0 tan beta L. This is the input impedance for the short circuit lossless transmission line. So here from equation 1 and equation 2, these two equations shows that input impedance of an open and short circuited lossless transmission line is a pure reactance. So the value of reactance can be changed by changing the electrical path length, that is beta L. So here the input impedances and reactances values changed by changing the value of electrical length beta L. So these two equations are input impedance of open and short circuited lossless transmission lines. Thank you. For daily classes and any updates, subscribe my channel Electronics for Gate by Kota Venkanna. My mobile number 630-5826-909. Thank you.